Guess what? X and Y intercepts. Yeah, let's figure out how we can use X and Y intercepts as a quick way to graph an absolute value graph. Recall that we've used X and Y intercepts to graph a regular linear equation. It's always about just plugging in 0, but how's that look if you do it for an absolute value graph? Let's take a look. So remember, the Y-intercept is when x is equal to 0. Hopefully that doesn't feel backwards to you. So I think we can just plug a 0 in for x. Now when you do that, you actually end up with the absolute value of 0 plus 4 minus 2. And of course, if you do a little order of operations, you get the absolute value of 4 minus 2, which is 4 minus 2, 2. So the y-intercept is at 0, 2. That was pretty easy, just plugging in a 0. My guess is that you could do a lot of that just in your head. But what about the x-intercepts? Well, this means y is equal to 0, but it also means when we plug it in that we've got a little bit more to work out. So let's plug a 0 in for y, but I want you to take a careful look at what we've created. Yeah, it's not a monster, but it's an absolute value equation, kind of like we solved way back in the beginning of the chapter. Yeah, you gotta like isolate the absolute value expression. So we gotta do like a little bit of algebra. Now, whenever you get the absolute value by itself, which it is right now, then you split the equation. Remember how you split the equation? One of the equation, the absolute value, equaling the positive 2, and then the x plus 4 equaling the negative 2. So we have to actually split this, and that's right, we're going to end up with two numbers. Okay, now when you solve, I don't know which side you want to solve first. When you solve over here, you subtract 4. That actually gives you negative 2. And when you subtract 4 over here, that's going to give you negative 6. Now what I want you to keep in mind is that both of these represent the x-intercepts. Yeah, both of them represent a point. So it looks like we have two x-intercepts. Now, don't forget, this is an absolute value equation. It's been since the beginning, so it does have a vertex. Remember, the vertex comes from shifting, looks like for this problem, shifting to the left 4, and then shifting down 2. So if I go to the left 4 and down 2, then I'm pretty sure I'm at negative 4, negative 2. Now that's the vertex, and that would be a perfect place to start my graph. You can put a little dot there at negative 4, negative 2. But how about these x-intercepts that are at negative 6 and over here at negative 2? Yeah, those would be good numbers to get on the graph. And then what was the y-intercept? Oh, it was up at 2. So that's going to be right there. All right, so we have our points, just to double check. This one's at negative 6, this guy's over at negative 2, and this one actually was at 2. Of course, we have the vertex, and look, we have our graph. Yeah, I mean, it's the same kind of graph that we've drawn, but the cool thing is here is we have the x and y intercepts that are part of that graph along with the vertex right here in the middle. Everything lines up nicely. It's a good answer. It's a good graph. So, yeah, when you do this, you're going to be able to plug in x equals 0. You're going to be able to plug in y equals 0. Keep in mind that when you plug in y equals 0, that you actually end up having to solve the equation a little bit. In other words, you have to split the equation. You have to go through that technical method. But you can still get the vertex and create a nice graph. So let's try it. Let's try it for another problem. What do we got here? Problem number 1, use x and y intercepts. Now, if I don't have this organized, you should still be able to go through here. with the X and Y intercept. Doesn't really matter which one you find first. What do you want to do? You want to find the Y intercept first? It's typically a little bit easier because all you're doing is plugging a 0 in for X. A lot of times that's something you can do mentally. Don't be fooled by the negative sign. It's still going to be 0 plus 5, so are we all right just writing 5? Again, that's 0, 5. Now the X-intercept, it's actually the X-intercepts because, yeah, we're going to set the equation equal to 0. Of course, that means you're plugging in for Y. But when you do that, you got to isolate the absolute value. Don't split it yet. Can't do that. You got to isolate the absolute value. So go through some algebra, subtract 5. Easy to do. Now, technically, I still need to get rid of the negative sign. Divide by a negative. If you really want to show that, you can. But now I can split my equation. Now the absolute value of X is isolated. So we're going to end up with equaling the positive and equaling the negative. So it looks like I've got 2 X-intercepts. And then don't forget about the vertex. The vertex is still part of the thinking here. Remember that if you add 5 at the end of the equation, your graph is going to shift up 5, and that would put us at 5. Now, interesting, if I go up 5, I get the vertex, which also appears that it's the same as the Y-intercept. Yeah, actually that's good, because when you start, when you're ready to start graphing this problem, and of course you get either your vertex or your Y-intercept labeled up at 5, and then you go and you label your X-intercepts that are also at 5 and negative 5. Hopefully you can kind of see how the graph is taking shape. That is a graph that's going to open downward, right? You've got this negative sign right here, and so a graph that opens downward is definitely going to have to pass through all of these 5s. And once again, we have a good graph. That's what we expected to see. Let's jazz things up a little bit here. How about a system of equations? Now be careful, this is a little different than yesterday. I don't have greater than and less than signs, so I'm not going to be shading, but I'm still going to be trying to figure out the graph of each of these. So, ready? Let's do the graph. Let's do the big one here, the absolute value graph. Y-intercept. Y-intercept. Plug a 0 in for X, right? I'm going to show it one more time. I get 0, get the absolute value of 0 minus 3, minus 4. I'm pretty sure that's going to be the absolute value of negative 3, minus 4. And remember, absolute value is distance from 0, so we just get 3 minus 4. Eventually we get negative 1. Okay, technically 0, negative 1. Again, that's your Y-intercept. X-intercepts. Feel free to pause the video because you should feel like that you can go about this. Remember, X-intercept, just plug a 0 in for Y. And then you want to rearrange your equation so the absolute is by itself. Once it's by itself, you can split it up. Okay, be careful. I wouldn't skip any steps here. You want to set it equal to positive. You want to set it equal to the negative. So I go through the solving steps. Looks like both these are going to require me to add 3. If I add 3, I get 7. I get negative 1. Technically, with a 0, because technically, again, it's an X-intercept. And lastly, I need a vertex for this thing. Remember, the vertex comes from shifting. Looks like shifting to the right 3. And shifting, looks like shifting down 4. Now, you're welcome to graph this. In fact, I would recommend graphing it. Go 3, go negative 4. You know, get your graph kind of in place here. I got a cat that's like, you can't see it or hear him, but he's kind of doing the cat thing. He's bugging me here. What what else? I've got a Y-intercept at -1. I've got an X-intercept at -1. And then I've got an X-intercept way over here at 7. Looks like I need... There's the cat meowing. All right, so good old absolute value graph. Okay, again, the Y-intercept is at -1. The X-intercept is at -1. And then over here, I was way over here at 7. Now, this is a system, though, and a system requires you to graph both equations, and ultimately, just so you know, we're going to try to find the intersection point. So we still got a little bit of work to do, but please don't find the vertex of this y equals mx plus b equation. Please just find the y-intercept and the slope, right? So my y-intercept is 2. We can kind of approximate that a little bit here. Looks like we're up here at 2. And then my slope is down 1 over 2. And if I go down 1 over 2, I'm going to end up basically with a shape that looks like this. Why does that keep erasing? So I go down. I don't want to add a comment. And we get our sloped line. Now, I had to fudge this a little bit because my lines are not supposed to have the same slope. So my green line eventually does crisscross. It does crisscross. It intersects at, here, let's change the color, at this purple point, and it intersects at this purple point. Now, just so you understand, it's actually those purple points that we're trying to find. Why are we trying to do that? Well, because when you solve a system, what you're actually trying to do is find the intersection of your lines. So how are we going to do that? How about a little substitution method? What happens if I substitute -1/2 x plus 2 in there for y? Let's find out. Excuse me. So, I feel like I'm going to need a little more space. Let's get her in here. We'll substitute -1/2 x plus 2. We substitute that in for y. I still have the absolute value of x minus 3 minus 4. Now look what I did. Okay, well, yeah, now I have an equation that's a little bit more super duper that I need to treat and solve like an absolute value equation. Listen, I still want to get this absolute value by itself. You always want to get it by itself. So all I actually need to do is add this 4. That's all I need to do before I split the problem. Okay, once the absolute value is by itself, then you split it to equal the same thing. In this case, that's -1/2 x plus 6. And you split it to equal the opposite. Now, the opposite would make a positive 1/2 x, but a negative 6. So, look what we've got. We've got a couple equations that need solved. Okay, this equation I'm going to have to add 3, and I'm going to have to add a 1/2 x. I know it's a fraction, but that's what you got to do. If I add a 1/2 x to 1x, I get 1.5 x. And when I add 3, I get 9. Eventually divide both sides by 1.5, and it actually shakes out pretty nicely to be 6. Over here, I'm going to add 3, but I'm going to subtract a 1/2 x. If I subtract a 1/2 x from 1, I actually just get a 1/2 x. Of course, if you add 3, you get -3. So if you multiply both sides by the denominator or by the reciprocal, multiply both sides, get that thing solved, you get -6. Okay, so I've got a couple points. That's nice. But guess what? I need the y value. Oh my gosh, where do I get the y value from? We get the y value from the original equation. I'm talking about the y equals mx plus b equation. So all I need to do here is plug in my 6 so I can get the y value. That's going to come out to be -1, right? And then I'm going to plug in -6. And that's going to come out to be 5. So I do have to go back and plug in, but when I do that, I get the y value again of 5, and I get the y value of -1. Phew. Now, what are those points right there? Well, those were those intersection points. And if you go over here and look at your graph, you should be able to kind of reason that, oh yeah, I put them in purple. I forgot they were purple. Anyhow, those 2 points right there look like they definitely are the 2 purple points. Here's -6, 5, and here's 6, -1. Okay. Remember, solving a system is a matter of finding intersection points. And so in case you got lost, that was the goal of the problem, to find those 2 purple points. Okay, we can do that. We can graph 2 lines. We can find those intersection points. Remember, we found the intersection points by substituting, did a little substitution method, and then we had to go through the solving. I thought we were just finding X and Y intercepts. Well, let's try it one more time. Okay, let's try it one more time. Y-Intercepts, X-Intercepts, and maybe a vertex, right? Now, the Y-intercept is when you plug a 0 in for X. Okay, so, we've kind of been doing some of that mentally, but that's the absolute value of -6. Absolute value of -6 plus 3 is really 6 plus 3. So we get 9, actually 0, 9, because it's a Y-intercept. What happens when you plug a 0 in for X? Excuse me, I meant for Y. Okay, well, as you've seen a few times, you probably should solve that. Now, when you go to solve that, you subtract 3 from both sides, and we actually get a little bit of a quandary. The quandary is that the absolute value cannot equal -3. Should I split this up? No. Actually, absolute value cannot equal a negative number. And so what we end up with is a conclusion that there's no X-intercepts. Now, how can that be? Well, if you actually go through the vertex thinking, you're going to shift to the right, you're going to shift up. And so if you go through that thinking and actually go over here and graph 6, 3, now here's 6, 3. Where's that Y-intercept? 0, 9, right? Like way up here, 0, 9. Wait a minute. If I try to draw my graph, my V shape, I don't get any X-intercepts, right? X-intercepts are along the X-axis. Well, the graph's not going to cross the X-axis, so it actually makes sense that we end up with a none. So once again, good graph, all is well. Thank you, X and Y intercepts. All right, now the back of the paper, I'm pretty sure there's some homework problems back here. Looks like you want to think about graphing with X and Y intercepts. Take a look at number 3. I did throw less than signs, so you're going to end up shading like we did yesterday, but you're still going to use X and Y intercepts. Here's a system. Fun, fun, fun. And hey, this is just a good old line, number 5. So make sure you don't find the vertex of that thing. All right, and a couple review questions down at the bottom. All right, we're getting into some deeper ideas, but let's keep learning, let's keep growing, and we're going to add X and Y intercepts to that knowledge.